pressures, any boat now. That's all the things that everybody's like, oh, the worst fear is bad. Ron Bennett's. Three of you are sure of this. There's also people that have seen that.
I know we work so well together. It's like if you were to take like Dennis Rodman, Michael Jordan, and Tom Barkley, and just like take them all and break them up.
Okay. Better. I'm taking notes better to me because your eyes had
So here we show three concepts of pressure through depth, density, and gravity. The deeper that the item or the pressure is within the fluid, the more pressure there is. You can see this because when Theo moves up the pressure and down the pressure from ranging depths, it changes pressure. So like the lower the pressure, the deeper the pressure it is. If here's the surface and here's the object, the higher the pressure is. If the object moves up, there's less pressure up here and there's more pressure down here. With density, he changes the density thing from ranging from honey and gasoline. So when he changes it to honey, which is a liquid that has a much higher density than gasoline or water per se, there's a much higher pressure. When he changes it to gasoline, there's a much lower pressure. Then when we talk about gravity, the stronger the force of gravity that there is within the pressure thing, the stronger the pressure will be. So when he moves it so there's an intense force of gravity when the pressure moves up, and then when he puts it at a much lower form of gravity, the pressure dramatically decreases.
On the end, so one of our experiments is like that. So that means on the end it's going to be like that.
So here we can see that the pressure changes whether there's an atmosphere or if there's not. So in the air, if there is atmospheric pressure, then it is equal to 1. But when Theo changes it and turns the atmospheric off, then there is no pressure in the air and there's a much less pressure in the water. When the atmosphere is turned on, there's more pressure in the water. It's also related to gauge pressure and absolute pressure. Absolute pressure is equal to the gauge pressure plus the atmospheric pressure. And the gauge pressure is equal to the absolute pressure minus the atmospheric pressure.
Inside physically, she's probably told you trends, what do you some data points? Simple data points and
So the concept of the continuity equation is very simple. The equation itself is that there's a fluid flowing in a pipe has a constant volumetric flow rate. So the equation is that A1 V1 is equal to A2 V2. V would be the velocity in this case. So if the area of the pipe is equal, then both of their velocities on each side will be equal. If the area of the second pipe, let's say, is smaller, then the velocity of the flow rate in the second pipe will be much higher than in the first pipe, and vice versa. If the pipe is bigger, then there will be less speed. Here we also have the concept of Bernoulli's principle, which states that the pressure of a fluid decreases as the fluid's velocity increases. So in the simulation, there's a much smaller area for the pipe flow, which means that there's a smaller area, there's much higher velocity. Now when we have the icon pressure in the area that has a much smaller flow rate and a higher velocity, the pressure decreases than the other area that has a larger area.